in the morning sessions to the earlier sessions too, you would have heard that AI has been around for 40 years, 50 years now. A lot of literature, that we reuse is still from the 1970s, 80s, the work done from them, that we kind of, put it into some use case context, etc. So as you can see, you have the RNNs, LSTMs, 1988, 1997. But in terms of the first language models using RNNs, LSTM, that happened in the 2012, 2013, 2014 timeframe, right? So that kind of tells you that there's a good body of work that was already done. Now it's more of the application of AI, because now we have the monetization opportunity with AI. That's when the deployment is happening. So all of that is fine, RNN, LSTM. So these are all the techniques that you have when it comes to understanding language, right? So language and image, more from a spatial versus temporal, they do differ. For language, you do need that temporal dependency to be taken care of. That's where RNNs and LSTMs were predominantly used. And transformer changed everything. Attention is all you need. Transformer is all you need. That's kind of a seminal moment in the AI industry. So 2017 is when transformers happened. Then you had its own evolution, and very fast evolution, by the way, right? I mean, these days, it's like in a matter of months, weeks, things change. So from 2017 to now, look at how much it has progressed, right? So the transformers was, more around, how you can do away with, how you can only do it with attention, right? You don't need any of the other, the LSTM, so on and so forth. So transformer that way was a seminal moment, and also in terms of the model size, if you see, we had data. Data is oil. That's what we hear. But then, how do you make sense of that humongous amount of data? So there are two things that happen. One is larger models because of the compute availability, number one, and the second thing is the use cases that came in, right? I mean, primarily, if you see even your OpenAI and whatever they've done with the ChatGPTs, it's a Q&A, question answering capabilities, right? But the fact that you had your, the contact customer support, contact centers, that was the dominant workforce, dominant use case that was there, that kind of got transformed. So the model, as a consequence, if you see the size of the models today, we are talking about 175 billion for the GPT-3. The GPT-4 will be magnitude order bigger than that. So how do you run all of these models? And now it's not just about the execution of the model. You do need to consume the data that comes, that is needed to train these kind of models, right? So from a computer architecture perspective, brings in a lot of demand, not just on the CPU architecture, but in terms of the kind of memory you have, the kind of data ingestion pipeline you have. So it kind of brings in all of those challenges. Purely speaking about the FSI sector, I'll come to that in a bit. But given the evolution, the speed at which it's happening, this I think Jan LeCun also said, by 2030, you will have across text, code, images, and video, you will have AI doing much better than humans. While it does kind of concern a lot of us on, from an impact perspective, societal impact perspective, but purely from a technology perspective, that's a very powerful statement to make, right? And today, if you look at it, text and images, AI is at a point wherein you actually are using it on a daily basis, right? Even on your phones, the fact that it is able to sift through the images on your phone and kind of show you faces, you can search based on faces, is down to some of those capabilities. But there are barriers as well as there are drivers. The drivers for sure would be the use cases, the enhanced creativity and productivity that it enables you with, and then the business use cases, and I'll cover a little bit of those FSI use cases that are driving it. But there are also those barriers, technology barriers, that will get addressed, right? Because there's a lot of research happening in that direction. Hallucination, it has been appropriated into the tech world. You kind of say models are hallucinating, and in fact that's true, right? If you have played around with any of these large language models or vision models also, put in a query, there are a lot of false positives, right? What we call as hallucinations. So that needs to be addressed. Then the bias thing, recently the Google Gemini is a good example of the same. So bias, there is an inherent bias in the data, then there is a bias that comes in as part of the the developer ecosystem. There is a certain bias that comes in. So how do you validate against those biases? And in fact, that will become even more important, especially for sectors like FSI, because they're very process oriented, they do audits. So how do you validate and confirm that your models are free of those biases, right? I mean, we have those popular examples of, denying loan to a certain person because of their background, right? So FSI, before they kind of go in and deploy these kind of models for a lot of their use cases, they absolutely would want to do away with those biases. In the morning sessions, in the earlier sessions, you also heard about as to why we believe, Intel believes that a lot of those AI will kind of start shifting towards the edge, and that's because of the trust privacy reason. I don't want my data to be available on some cloud and some entity kind of make models out of it. Let me kind of do a fine tuning on my PC itself, on my laptop, right? My documents, my financial records. Can I have those models running on my laptop? And again, if you follow some of the patents that are happening, right? I mean, research papers to patents, one good indicator of it is, patents kind of start happening when, productization is very imminent, right? Some of those technologies start getting converted, research papers start getting converted into products, that's when patents happen. If you follow some of those patents that the Apples or some of those consumer product companies are doing, you will see that they are doing a lot more patents on AI when it comes to the edge, right? And even Google, if you track Google, Apple, you will see a distinct change that will happen. The next version of Siri, September sometime they will announce. It will start doing a lot more than what it was doing today, right? So the point is, the security trust, that's extremely important because, security as a consequence will drive the trust, right? Because that data is not leaving your device, your premises. And hence, you can start deploying those algorithms. So that's one of the barriers because again, there is no easy way. How do you check for bias, right? There are a bunch of techniques in again research papers, but how do you convert that into a deployable solution? There are no easy answers yet, right? Explainability, they talk about explainable AI, so on and so forth, but all of that is fine. How do I combine all of that and get a view of if an algorithm that I'm using with, what is the kind of bias that the algorithm comes with? The last one is on the data. One of the enablers will be data quality. Again, in the morning sessions, they talked about how 20% of the AI data, the world data, will come from India. But then, one of the first things I learned in computer science is, garbage in, garbage out, and that is as evident, as applicable today as it was then. If you feed in garbage to these AI models, it will output garbage. So the point is, and I'm not saying data is garbage, but the point is there needs to be a very healthy data pipeline that allows you to qualify the data that you have used to train your AI models, and then basically get you the models. These are not easy problem statements because if it were easy, they would have been solved a long time ago. Right? So moving on, what are the key business artifacts that generative AI? What is that they can generate today, right? So in terms of artifacts, as you can see, there is audio visual. I'll not get into the details of it. We have see that in the newspaper, we mentioned in the media day in, day out. Programming and data asset, for us sitting in this room, this will be a key disruptor, because it kind of, puts the demand on the coders to be able to debug what the AI is spitting out, right? Very soon, subject to the legal barriers being overcome with respect to the IP, intellectual property, etc. You will have co-pilots coming in and helping you with the coding, right? And that will be one significant change that we will see in the next 5 to 10 years, and that will apply across all sections of coding, right? Right from your hardware to whatever software we are doing today, whatever language we are doing today. Right? Then the natural language, that's been the driving use case for a lot of those, RNNs to LSTMs to transformers. So that anyway, we are at a much better position today as compared to 2-3 years ago. On the learning methods, I think this is another one that will increasingly start disrupting the strategies and tactics, right? You would have heard about the AlphaGo game and the way that kind of revolutionized or kind of beat the Lee Sedol, the world champion. Right, and chess back in the days of Garry Kasparov, but purely from the ability of AI to reason, right? What it brings forward is the reasoning ability of AI, right? Today, again, the large language models, they're not that good when it comes to reasoning, right? And again, a lot of good examples that you will find in the media. So a lot of work is happening, reinforcement learning based techniques will come in, and some of those strategy related aspects, AI will get in there, right? And as well as tactics as a consequence of that. Yeah, so talked about a little bit, maybe I'll just kind of draw your attention to some of the organizations, some of the key players across all of these vectors that you can that are there. Right from 3D assets generation to text generation. Lot of familiar names and lot of names there that will grab your attention in the days to come. One thing with AI is, they will be given a Sam Altman will not stick his neck out and say what will happen 1 year down the line, because the industry, a lot of what is happening in China is not known, by the way, right? We know what's happening in America, we don't know what's happening in China. So nobody will put their neck out and say, what will be the state of affairs 1 year down the line. And a lot of these names can disappear. A lot of these names will be some of the big companies. OpenAI. Musk say they shouldn't be called OpenAI, but how many of us actually knew OpenAI say 2 years ago, right? And today they are a $2-digit billion-dollar company, right? And talking about raising $7 trillion to do AI chips, right? So that's the kind of power AI will bring into this ecosystem, and again driven by use cases, right? There will not be a segment that will not be impacted by AI. AI truly is kind of an horizontal enabler, right? It's not even like it's a computer science topic. You should have, this is kind of digressing a little bit, but you will see AI as a stream kind of getting introduced across different career prospects too, right? You will have, and that's already happening in the West, you will have doctors also coding, because why is that the case? That's because when it comes to understanding the data, you need domain experts. And if the domain experts can also do the coding, that's more power to it. That's where the coding capability, the co-pilots will become extremely important. So if you go to a John Hopkins, you will have the doctors. In fact, and I'll give one example. So we were looking at one MLOps pipeline called Kedro. Some of the biggest contributors to that MLOps tool were doctors, right? Because they were using that MLOps for their deployment into the hospitals, so on and so forth. But the point is, the co-pilot with basic coding skills and the AI awareness, you will see a lot more transformation happening across segments, right? And it's not just computer science kind of a stream. And the names too will change as a consequence. For example, there is a healthcare. I'm not able to recollect the company. It's essentially a healthcare company, and they're now putting out large language models in India, right? And the question came, why is a healthcare company putting out large language models? The question is, why not? Because when you have access to the data, and when you have the technology and the techniques available, it will enable a lot more capabilities and use cases, right? Again, in terms of the list of use cases, this is what we think are the use cases, but don't be surprised if that list looks totally different, year down the line. So when it comes to financial services industry, a lot of use cases mentioned there, and again, my simple rule of thumb is where there is data, where you have data repository available, you can actually apply large language models, or you can apply AI and make sense of it, right? There are some examples already. Sorry, did I jump? There are some examples already. So I think the animations went away. I was hoping for animation. So if you see risks management, there is one large language model that has come in called FinGPT. There is one more for natural language to query. Bloomberg has done that. Bloomberg. Why is Bloomberg doing large language models? Answer is why not? Right? That's what will happen. So Bloomberg has come with its own large language model, and then there is a FinBERT at the end, financial sentiment analysis, right? One of the marquee use cases that will see a lot of disruption, and it's been talked about as a billion-dollar industry already, is the fraud detection, right? Financial fraud detection, and fraud detection across segments actually. But financial fraud, and some of this financial sentiment analysis goes into being able to detect frauds, right? So talking a little bit about FinGPT, how does an architecture look? The idea, it's a busy slide. Most of the slides are busy here. But the idea is to show the complexity of what it takes to build AI, right? Now, and that's the reason why no one company kind of, put a tent there and say AI is something that I've cracked, right? So on the left is what you have as the typical layers that you need when it comes to addressing AI. So infrastructure at the bottom, that's the compute infrastructure. Then you need the foundational models, what you call as your ChatGPT. That's one of the foundation models. And there are many foundational models depending upon the kind of use case you're looking at. There is one foundation model for the code, so on and so forth. Then comes the AI platform. That's where you kind of play around with the model. ingest the data, feed the data to it, and start making inferences, start implementing your use cases and the applications as a consequence. So if you look at a simple diagram like that, if you blow it up in terms of what a FinGPT looks like, and look at the kind of data sources, right? I mean, all of them. I'm kind of talking from a coding perspective, right? I mean, this is a nightmare, hell, in the sense of being able to ingest different kind of data. The data schemas are different, the way the language used is different. I mean, Twitter, 140 characters until a year, 2 years ago, people used a lot of short forms. Today they don't. You can write essays on Twitter. I mean, how do you ingest data, right? I mean, and when it comes to there are GPTs happening in the medical domain, right? The data again comes in different schemas, right? So the challenges when it comes to data, that's why I kind of go back to that garbage in, garbage out. It's not because the data is garbage, it's because we still have not cracked how to kind of ingest data in a meaningful way, right? But the diversity of data is pretty humongous. And though it's some arrows going there, the complexity, a lot of complexity in building LLMs is there, right? Why is it that they kind of go and OpenAI then converted themselves into a for-profit organization? Because of the expenses involved, because of the infrastructure that's required, they cannot just sustain on a open source kind of a modality, right? So the complexity is pretty significant getting into data engineering, and of course the LLMs on top. Training wise, there are not many organizations in the world who can do full training. It's more of fine tuning is what we do. That's where you see LoRa's and the RLSP coming in, and then of course the applications on top, right? Now it's not one, as I said, it's not one organization. So for a FinGPT, they would have used multiple third-party ingredients to put a solution all together, right? So jumping into, given its Intel event, I'll jump a little bit into, the infrastructure layer. That's what Intel provides. What is it that Intel provides? Now, one of the few organizations which kind of give you a portfolio that kind of can traverse the continuum, as Santosh said in the morning, the continuum from the cloud to the edge, right?